Hello guys, welcome to my YouTube channel. Today we discuss about gradient descent method, which is the most important one. This concept asks more time in the exam point of view. The main definition of gradient descent method is it is an optimization algorithm commonly used in machine learning numerical optimization of maximum or minimum value of function. It is also called as steepest gradient. Here means in gradient descent method is used mainly in machine learning. To solve the problem of using of this concept is followed some steps. The first step is define objective function as z or f of x comma y. Here means in the first step you have to define the objective function as z, which is given in the problem. In second step we have to find grade f. This symbol is indicated as gradient or grade f equals to using this formula we find out grade f for objective function, that is grade f equals to dou f by dou x and dou f by dou y. By this we find out the grade f value. In the step 3 we find out the Hessian matrix small h. In the previous video we know that how to find the Hessian matrix for 2 by 2 matrix or 3 by 3 matrix. Okay. In step 4 we have to find the iterations using some procedure, that is we are having some procedure. By this we find out the iterations until the value of optimality is equals to 0. Okay. Here in the iterations we follow some procedure, that is the first one is find s1 value using that minus grade f at x1 value, that is in the question you have to find out that the given question is gradient method or not, gradient descent method or not. Is in the given question we can see the z objective function value and also one given point. By that two conditions only we can say that this is in the gradient descent method or not. So first of all we have to find the s1 using minus grade f at x1 point. This grade f, that means this in this value we have to substitute this point, we find out the s1 value, then we have to transport that s1 value. Next I will explain you how to do this all procedure by using one problem. Let us listen that how to find out s1 lambda 1. Next we will discuss about in the problem. Second we have to find out the value of lambda 1 using s1 transpose into s1 by s1 transpose into Hessian matrix H into s1 for finding lambda 1 value. In the third step we have to find out the x2 value using the formula is x1 plus lambda 1 into s1. We know that here we find out the s1 value and lambda 1 value. By using this value we find out the x2 value. After that in the fourth step procedure we have to check the optimality using the value of x2. This x2 we will substitute in the f value, grade f value, to check the optimality. If we substitute this value in f, it is equals to 0, then we stop the procedure here only. If we do not get the value equals to 0 in the optimality, we will repeat the same process by changing the stages until the optimality get in 0. So here we start the problem. Here in the first iteration only we get optimality value is 0. We stop here only. If it does not get equals to 0, we will follow this same procedure, means iteration 1, iteration 2 until the optimality is 0. If the optimality is get 0, we will stop the procedure here only. Let us do an example problem to understand it very betterly and easily. Here the given question is minimize f of x comma y equals to objective function is x minus y plus 2x square plus 2xy plus y square. Start from x of 0 comma 0. use gradient descent method. I first only said that you to find out is this problem is in gradient descent method or not is the main condition are here giving z function and also as well as one point. By seeing these two conditions only you can say that it is in gradient descent method. It is a trick to find out this problem only. Don't confuse. You can see if there is this one point and objective function, you can say confidently that it is a gradient descent method problem, related problem. And in the exam point of view, you can easily done this problem and get good marks. Let us start the problem. Here given that z equals to x minus y plus 2x square plus 2xy plus y square, and values take is as x1 equals to 0, 0. It is the step 1. We have to write the given conditions here. This is step 1. In second one, after that we have to find out the grade f value, that is using dou x by dou y. Here dou x means we have to differentiate this z function with x, that is here dou f by dou x dou f by dou x, that is dou by dou x of x plus minus dou by dou x of y plus dou by dou x of 2x square plus dou by dou x of 2xy plus dou by dou x of y square. Here we know that dou f by dou x means we get here x cancel, we get value here 1. If here we have to differentiate with x now, here have different variables, so it is directly values become 0, plus it is in the form of x power n formula, that means n into x power n minus 1. By placing here n plus we place 2 value, we get value is 4x plus here x cancel, remaining we get 2y, and this one also 0, that is dou f by dou x, we get the values x plus 4x plus 2y. Okay, 2y. Like this only dou f by dou y means we have to differentiate this function with y, that is dou by dou y of x minus dou by dou y of y plus dou by dou y of 2x square plus dou by dou y of 2xy plus dou by dou y of y square. We get dou f by dou y is 0 minus 1 plus 0 plus 2x plus 2y. That means dou f by dou y we get value is minus 1 plus 2x plus 2y. So we know that grade f equals to what we have, dou f by dou x value means dou f by dou x, dou f by dou y. In this place we substitute these values, that is dou f equals to dou f by dou x means 1 plus 4x plus 2y, and dou f by dou y means minus 1 plus 2x plus 2y. Now we have to find out after that we have to find out the Hessian matrix. We know that Hessian matrix mod H equals to dou square f by dou x square, dou square f by dou x dou y, dou square f by dou y dou x, and dou square f by dou y square. Here already we have dou f by dou x. We have to find out the dou square f by dou x, where we have to differentiate with x, again differentiate x with this value, that is we get 0 plus 4 plus 0, that is dou square f by dou x square, we get value is 4. And same as dou square f by dou y square, we have to differentiate with y. With this we get 0 plus 2, that is dou square f by dou y square is value is 2. Okay na? Okay. Now we have to find out dou square f by dou x dou y. That means this is dou f by dou x means what? We have 1 plus 4x plus 2y. We have to find out dou square f by dou x dou y. This is dou f by dou x. Now we have to differentiate this with y. That means we get value is 2. Same as dou square f by dou y dou x means this is dou f by dou y. We have to differentiate this with x. So we get value is 2. That means here Hessian matrix H equals to dou square f by dou x square, we get value is 4, and this value is 2, and this value is 2, and this value is also 2. This is the Hessian matrix, which is in the form of 2 by 2 matrix. After this we have to find out the iterations. That is iteration 1. We have start the main concept here only. In iteration 1, the first procedure is what? We have to find out the S1 value. S1 equals to minus grad f at x1. That is S1 equals to minus grad f value is what? That is 1 plus 4x plus 2y and minus 1 plus 2x plus 2y, and the x1 point is what? 0, 0. That means S1 equals to placing this 0, 0 in x and y, we get minus of 1 plus 4 of 0 plus 2 of 0 minus 1 plus 2 of 0 plus 2 of 0. We get value is S1 equals to minus of this all 0 and this all 0. We get 1 minus 1. That means S1 equals to, by multiplicating with minus, we get value is minus 1 by S1 transpose means this will change in other direction, that is minus 1 like this. S1 is 1, S1 transpose is 1. Now the second one is we have to find out the lambda 1 value, that is S1 transpose into S1 by using this formula S1 transpose into H into S1. By placing all these values in this place, that is S1 transpose value is minus 1 into S1 means minus 1 into Hessian matrix 4 2 2 2 into minus 1. By substituting these all matrices, taking this as A matrix and B matrix, this is taken as A matrix, B matrix and C matrix, we find out the value of lambda 1, that is we get the value of, by substituting these values in the cache, we get the value of lambda 1 is, get lambda value 1 value is 2. By substituting this in cache, we get lambda 1 value is 2. Step 3 procedure, we have to find out the x2 value using x1 plus lambda 1 into S1. That means x1 value is what? 0 0 plus lambda 1 value is 2 and S1 value is here, that is minus 1. We get 0 minus 2 here lambda 1 value is 1 and here also lambda 1, we get value is minus 1, that is x2 value we get minus 1 and 1. Now we have to check for the optometer in step 4, that is grad f at x2, that is 1 plus 4x plus 2y minus 1 plus 2x plus 2y, we get minus x2 means minus 1 we get 1 plus 4 of minus 1 plus 2 of 1 minus 1 plus 2 of minus 1 plus 2 of 1. We get the value is here 1 minus 4 plus 2 and minus 1 minus 2 plus 2. We get here minus 2 cancel here. 3 minus 1 4 means minus 1 minus 1. Here you can check in the optimality. It is, you have to check at optimality is not equals to 0. Here optimality we get minus 1 which is not equals to 0. So we have to go for the next iteration and follow this same procedure. So next go for iteration 2. So here the first step in the first procedure step is finding S1, that is S2. Now in the next step we find out the S1 value. Now here S2 equals to minus grade f at x2 point. That means this point. Here this you have to check here this point. So here minus of 1 plus 4x plus 2y minus 1 plus 2x plus 2y at x2 means we have the values minus 1 comma 1. So minus of 1 plus 4 of minus 1 plus 2 of 1 minus 1 plus 2 of minus 1 plus 2 of 1. We get value minus 1 of minus 1. By multiplying with minus we get 1 comma 1. This is S2. S2 transpose means it is like this direction. This is S2 transpose. The second one is we have to find out the lambda 2 value, because it is the iteration 2 process now. So we placing all are 2. That is we have to do that x2 plus lambda 2 into S2. That is here x2 what we have, x2 is minus 1 na, minus 1 na, plus lambda 2 value we have, so sorry here we have to lambda 2 value. Now we have to formulate S2 transpose into S2 by S2 transpose into H into S2. By placing S2 means what we have, transpose 1 into 1 by 1 into Hessian matrix means 4 2 into 1. Here by placing in the Casio we get that this lambda 2 value is something 2. Now we have to find the x2, that is find out x3 equals to, that is x2 plus lambda 2 into x2. That is here x2 value is what we have, minus 1 comma 1. That is we write here minus 1 plus lambda 2 is 2, x2 is 1. So here minus 1 plus 2 we get minus 1 plus 2 we get the value is 1 3. That is this is the value for x3. Now the fourth step is we have to check for the optimality, that is grade f at x3. That is 1 plus 4x plus 2y minus 1 plus 2x plus 2y at x3 means x3 value is this, that is 1 comma 3. That means 1 plus 4 of 1 plus 2 of 3 minus 1 plus 2 of 1 plus 2 of 3. We get 1 plus 4 plus 6 minus 1 plus 2 plus 6. We get the value is 10 11 7. Here optimality not equals to 0. So we have to go for next iteration until we have to follow these procedures same these procedure and changing the only tags for next iteration. If we get this value, optimality value is equals to 0, then stop here only. The problem is complete. If not equals to 0, we have to repeat the iteration process and until the optimality equals to 0. If we get the optimality is 0.0 also, then you stop the procedure at that time only. That only the answer for our problem. If not equals to 0, then we have to continue the process until it is equals to 0, the optimality equals to 0. For this problem we get the iteration optimal to 0 for iteration 5. Up to iteration 5 we complete the procedure for this problem. So hope you like the video, guys, and I also hope that you understand this concept also very well. So like, share, comment and subscribe my channel and click the bell icon to be notified every update from my Smart Studies YouTube channel. So most of the people not subscribing the channel, only viewing the videos. Please subscribe and support me. Thank you, guys. Hello guys, welcome to my YouTube channel. Hope you people like the video. Keep supporting me by subscribing the YouTube channel and like, share, comment and click the bell icon to be notified every update from my Small Studies YouTube channel. Thank you, guys.